All right, everybody. Welcome back to Jetson AI Lab. Thanks for joining us this week. To the date is August 6th, and we have lots to cover, updates on the OpenVLA. Asier is going to talk about Gemma 2B, Gemma 2 2B, which has like really great performance up to GPT 3.5 level and has it running on over Nano. Lakshantha from Ultralytics is going to talk about a new YOLOv8 page that they made for Jetson AI Lab, which looks really nice. But first, I believe Patty's on the call, and she has an invite to extend to this robotics event that's occurring at headquarters in a couple weeks for those of you that might be in the Bay Area. Okay, there you go, Patty. Thanks for screen sharing the agenda here.
Yeah. So, hey, folks, can you guys hear me okay?
Yes, we can.
Thank goodness. All right. So, hey, I'm Patty De La Fuente. I'm one of the solution architects that support the civilian team, the public sector here in the DC area. We are leading what's called a robotics and autonomy day in headquarters. So that's in Santa Clara. It's going to be an in-person event. It's on August 21st. And it's West Coast time, but it'll be from like 9 and then to 5, and there'll be a reception afterwards. And Jetson is also making an appearance. That we've got some of our top leaders and engineers that are going to be doing some awesome demonstrations. So the ask is, if you're interested, this is sort of geared towards the federal sector. But if you're a vendor doing business with the government, or if if you're a researcher, we do have some academics, researchers that are participating as well. Let me know if you're interested and you're able to attend, especially if you already live on the West Coast, because I realize it's hard to get travel and everything. Reach out to me if you're interested, and I will then connect with the coordinators and get you on the invite list. So I'll share my email info in the chat, and if you're able to make it, great. So that's all. Just wanted to share that invite and see. It's coming right around the corner. So I think there are quite a few folks in here that might be interested. So all right.
Yes. Thank you, Patty. And any of you in the group, feel free to reach out. Patty, I don't know if you want to like drop your email or on like LinkedIn or whatnot in the chat. And if you're still looking for people, you can like post it to the forums or our LinkedIn. Obviously, that is a very stacked agenda between Deepu, Rev, the group guys, Jetson, everybody from like NVIDIA Robotics is going to be presenting the roadmap. So if you want to see our vision for the next, year, 2 years, 5 years out, where we're going with this, highly recommend you go there and join it and meet all the team in person. It will be a great event. All right. Thanks so much, Patty.
Thanks.
All right. With that, let's dig in to what we've been up to the past couple weeks. Okay. Here we go. Can you guys see my screen? Okay. Yeah, I'm sure this is going. All right. Can everybody see this all right? Take that as a yes. So where we were at last week or 2 weeks ago, I had this all running against like the data sets, and we were getting like good accuracy on the data that had already been trained on. And I just started hooking it up to the simulator, and now we've done like a number of fine-tuning runs, and it's like starting to run through the simulator and grip things and start to stack them and follow the task that we trained it to do. It's still not perfect. There's still a lot of tuning to do, I believe, since the original OpenVLA was trained on like real world data, but it seems to like do pretty good. It like tries. A little later, I'll show you like telling it other commands. The success ratio on this block stacking task is still not very high. I would rate it between like 33 and 50% or so. So we're still working to continue tuning this, and I've done a lot of these LoRa's on the Jetson, all of these different like experiments that I've done with like different configurations, starting from the most basic one where I think I just like exported 100 episodes out of this simulator for the block stacking. And because that's what the paper said, like, oh, fine tune it on 100 episodes. I think this was just one epic, because each episode is like 100 frames, and then each step, the step meaning training step, is 32 images or something like that, or 16 images. It's batch size 8, and then it does 2 batches per gradient accumulation step. And all this is configurable in like these training scripts that you can run, which we'll do the tutorial for once we get this working better. So this was the first LoRa that I did, and the accuracy on the tokens was quite good, but it still did not come out to have like real world performance in the sim. I think it was only came out to like 85% accuracy when you evaluate it out of tree. And it turns out the accuracy of the output tokens is not equivalent to the success ratio of the actual agent, because it can only take, one mess up in the whole thing for it to derail the entire episode. In my experience, it takes like 95% plus accuracy in like the training to be functional whatsoever. So, and all these ran on Jetson, AGX ORAN. I started increasing like the LoRa size. It initially recommended LoRa rank 32, and it was only training on like 0.05% of parameters or something like that. And over time, I increased the rank up to 128, which got me up to 5% parameter coverage, and was using like 59 out of 64 gigabytes of RAM to do that, and would take about 24 hours to do the LoRa on it, and started like increasing the size of the training sets, started increasing batch sizes and other things, and was just like continually evaluating all of this. And every time I would do it, the accuracy would go up by like a few percent, but was still not really like getting there in terms of being able to like stack the blocks and actually complete the task. It was then, after I felt I went about as far as I could go with this on the Jetson, and it was like increasingly taking more time to like do all these experiments. I have this like list of all these things that I want to try with this to get it working better on out of distribution data. And the experiments were just like taking too long. I did actually get this running on multiple JAWs at multiple AGX ORANs at one time. And the instructions for doing that are here on their GitHub. This is like the fine-tuning recipes that you can follow. Basically, I just followed this and did the same instructions, ran it in the container. I had rebuilt PyTorch with more like distributed features with NCCL enabled and like other things in there to make it working, and did test that like the multi-node LoRa worked. I was able to run it on multiple AGX ORANs that I have here, even though that's not a really realistic use case for folks, as I only assume I'm going at this like normal developer experience, right? And normally, like you might have a Jetson, but probably don't have like a larger cloud system to access to train all this on, as neither do I. So I went about as far as I could with the actual LoRa's, did a number of those, got DDP, data parallel training in PyTorch working. That's where it basically runs an independent instance on every device and just trains multiple data streams in parallel. It does not split the model between multiple devices. When I went to try that, it still used too much RAM to be able to do full fine-tuning on the Jetson, even with 64 gigabytes RAM, because it uses a lot of extra system CPU memory for just like loading the data set and things like that. Hopefully when we get Thor and much more memory, then we will be able to do this all on board. But it turned out it was, to make the jump to like the full fine tuning wasn't bad. I just like rented one of these systems from Vast for like, it was like, took like an hour and cost like $20 to do it. I ran it on one of these. I don't know if any of them are up here right now. I ran it on an 8X H100 system. And this system is like really nice that they have here. Oh, here they are. I think it was this one. It was like $25 when I rented it over the weekend. And the actual fine tuning of this took like 50 minutes for 500 episodes for 4 epics. And here are the training results from that. And it did get much higher accuracy. It took way less training steps to do that because it was training on like the full parameters. It fine-tuned the SIGLIP and Dino V2 vision encoders as well. And there's a lot of cool system stats in here that it collects. And it was a lot of fun learning about these cloud systems and how you do it. The Vast and RunPod and like all those other ones, those are really easy to use for like individuals like ourselves, where you just like quickly spin these up. And there's all these container images on here, much like Jetson containers, but for the cloud, obviously. And most of these come out of like NGC and whatnot. So I just spun up the PyTorch image and installed the OpenVLA repo on there, and everything just works pretty much because it's x86, which is all this stuff was natively intended for. Okay, so that is to say that with the full fine tuning, it did appreciably better. It like jumped 5+% in accuracy there, and still needs more data. What I'm working on next is hooking up this MimicGen simulator directly into the training scripts, which you can find in the repo here. So initially you would start out doing the fine-tune script, which is for LoRa's. And then if you want to run the full FDSP, that is in the train.py one. And this all loads like data sets in RLDS, TensorFlow dataset format now, like from disk. And in order to generate the MimicGen data, it's like first I run that process, then I convert it from HDF5 to RLDS, and then transfer it to this system and load it in there. And all of that adds like several hours extra to the workflow. But if I hooked up the simulator directly into the trainer, it would be able to, have unlimited data. It would not have those extra export steps in there. And I think eventually is where things are going with this. And we're kind of out in front here, kind of like proving these workflows for other folks to follow, internal teams in NVIDIA, us here in the community. So if we can get this to work and show that with unlimited data and without repeating any epics, it's able to generalize more in like out of distribution data sets and whatnot, then that will be really good for folks to follow in. Here is a gift from yesterday showing him like actually stacking the blocks. So it does work, just like not enough yet. Although proof of life of this is significant based on like the natural language component, its ability to follow instructions. So even just getting it to this point, I feel is over like a huge hurdle that we've all achieved here. And it required like a insane amount of attention to like all of the data sets all lined up through all the conversions and like the action spaces, the normalization coefficients, all of that like made it all the way through to the end based on like what the sim expected and what the model expected. And it was a lot to make sure everything all lined up. Obviously this is, I guess it did stack them, but it seems like after it does stack them sometimes, it then likes to knock it off, because in the training sets, the episode ends right as the blocks get stacked or the goal is achieved. It doesn't really, the simulator doesn't simulate what happens after. So I like need to like add that so it retracts itself back to the origin position of it. But some of those things in there are like minor issues that we can tweak. This is running in real time on the AGX-01 right now at 2 FPS with FP8 quantization on the model, which I've determined has like next to no quantization loss versus the original. And the int4 does have like 5% quantization loss, which unfortunately does seem to translate to some behavioral characteristics, because even like you go from 100% token accuracy to 95%, that as we've seen, we're already getting 95% token accuracy, and it's still not perfect here. So yeah, and I think there needs to be a little bit more like depth image in it. It seems to have problems with like, it thinks it's stacked. It thinks it's right above, but it's really not. The input resolution to the model is very small, 224 by 224. So it has spatial limitations in like the resolution that it can achieve. And I know sometimes too, it kind of like, it gets stuck in like mid pick or whatnot, because it's confused if it's like coming or going, because OpenVLA doesn't have any past state or anything in there like it. So there are lots of enhancements that we can do with this, and that other architectures have gone and started implementing as well. Like, for example, this other project took OpenVLA and added chain of thought and multiple subtasks onto it. And so there's already research coming out that builds on top of OpenVLA and these other vision language action models, which fortunately now we are well prepared for, that we have all this infrastructure, inferencing, training, all of that lined up to get everybody into physical AI and things like that. So I'm sure there will be huge bodies of work coming out that build on top of all of this. Some models will be very big. For example, this is like a gigantor ensemble that combines a VLM with grounding Dino, AL segment anything, and like kind of throws the whole kitchen sink in there, plus Gemini, to see if like, can it like actually do this, which I'm supportive of in like the research to see if it's possible with, you know, everything state-of-the-art models, everything you got, you know, what can we do with that? And then folks like us kind of take it and distill it down into the mini versions using small language models and things like that. And they were pretty vastly able to improve their success rate. And soon I will start measuring the success rates of these in simulator as well, once we get it tuned to a little bit better, where, you know, there's actually something to measure. I would say right now we're like kind of like right around here, which is actually kind of consistent with what they're measuring. But obviously we want to keep doing on like the blocks. In my opinion, it should just nail that like every time, considering like what it's able to do. I think the major issue is this was trained on 900K episodes of real world data like this. The thing is, though, with the OpenX embodiment data set, yes, this is 900K episodes, which represents like a lot, but still is not, it's like a drop in the bucket compared to what Llama and these other GPTs are trained on for like trillions of tokens. So they took these 900K episodes and then trained it for almost 30 epochs in there. And there's roughly 100 to 120 frames per epoch. Or I'm sorry, there was roughly 100 to 120 frames per episode. So they might have been off by like an order of magnitude by like how much data is really needed to make a generalizable foundational model in this. Another interesting thing is like this chain of thought agent, it retrained from scratch on top of the prismatic via VLM. It did not reuse the OpenVLA trained weights. It just like started back over from the VLM, which is, this is essentially where OpenVLA started too. So it remains to be seen like how much of this we will be able to leverage. I didn't mean to test just going back to the original prismatic VLM or using VLA and other approaches before we sink too much time and compute into this. to see what will actually transpire. But I think it is promising that we will be able to do this, and learning all about like the fine tuning and going through all this has been extremely valuable. We had done fine tuning in the past for like object detectors and image classifiers, ResNet, SSD MobileNet, YOLO, all running on Jetson. Obviously, this is like a huge step up in terms of the compute complexity and data set requirements and everything. But at its core, it's like the same thing. It's not really, it might be harder to get it all loading, and the scale of the data is much bigger to the point where you can't really collect it yourself. Like on the in our previous Hello AI World tutorials, you could go right in here and do training for like object detectors and collect your own detection data sets and things like that. But that's a little bit infeasible with the scale of data here. Like in previous CNNs, we would just go in here and like annotate all of this stuff. And but what's really exciting about these simulators is like it just collects all of the data for you. I did have to add in the natural language component of this to get it to do that, but after that, it was able to go off and do it itself. Okay, one exciting thing about this is like it does follow instructions generally, other than just like what prompt was in there. You can tell it to do things. Let's see if I can remember how to figure that out here. Okay, so basically I need to disable the instructions that come from the sim. This graph is kind of complicated because it's all like looped back on itself. Okay, and then disabled the one that goes to the overlay here too. Okay. So I'll just tell it to touch. All right, ignore the overlay being messed up there. All right, so now I went for the green block instead of the red one, which normally it would go for the red one all the time. And then it instantly changed its task to pushing the red one instead. So it does well at like left, or like push the block on the left, push the block on the right, green, red, or like I want to add domain randomization on this so it'll be all like different colors, and then like really train it on that. And then I will like release a tutorial that anybody can do and follow. I want just like a minimal amount of like functionality that you can show here. Let's see. Will it follow spatial instructions? Let's reset the episode here for it. Does it go for the right one? Thinking. Okay, yes, it kind of did pick it. Sometimes I think that it having no concept of like its previous state, sometimes it does get like a little bit frozen. It doesn't remember like what it had done. When I train a more serious version of this, it will definitely have the prior state vectors in there, just like this one added in, along with for higher end ones like force feedback and other things where we're like really going with this. Okay, with that, since we have like other speakers to talk today, I'll wrap up on this, but we are going to continue working on this and also investigating these other architectures. For example, Nigel had presented a few weeks ago, it started looking into this Aloha-based model, which has had a couple generations of this out. And the latest versions of this use VIT-based as opposed to language models. And this runs, he set it up to like 100 FPS. It does not have the natural language integration in it, but could be added with a function calling LLM on top. So there are architectural things. Like we could have a fast, slow approach here, where like a VLM takes a picture every second or two of the scene and tells the model how it's doing. And like an LLM controls all these other smaller policies, either RL based or this is like an 80 million parameter VIT. So it's not, we're not predestined to say like, oh, it has to be LLM based, VLM based VLA that runs the full thing every frame. We'll be open to experimentation here throughout. Martin, you had a question real quick there.
Yeah, I wanted to ask, I already posted in developer forum that all these AI multimodals models right now, they're kind of running on a table. But if you put it on a robot, they kind of need to higher bandwidth to stream the data out. So I would like to know about the higher bandwidth like Wi-Fi chips. Right now it's like the Wi-Fi 5. So for example,
well, I think I saw
Jetson
like
or somebody-
Wi-Fi 6. Yeah, Wi-Fi 6 started. I don't know about the Linux kernel support on Jetson, but well, obviously the whole point of why we're going through such trouble of doing this is the on-device compute, right? And that will be currently limited to like the Jetson devices for the AGX devices. This would definitely run on Orin NX. I have the benchmarks here in another tab. Let me shuttle these over. Fortunately, it would seem that like 3 Hertz is actually possible to do. So like we get up to almost 3 FPS on Int 4. This is now over, FP8 is now over 2 Hertz. Yeah, we're doing 2.1 at that now. So I do gradually get like 10% here and there, which is nice. These quantization errors have also come down as I like meticulously tracked differences versus the upstream implementation. And there are other little tricks I have in here too, such as like repeating the previous action in the frames where it doesn't come up with one, because the simulator runs faster than the actual VLA is, which is a handy thing about having this whole multi-threaded environment to do all this. I tried like updating the actions as they come in each dimension. That didn't like work very well. What I do want to do is one of these retrainings is to like accumulate actions from multiple frames so that it like looks ahead as opposed to only training itself on the current frame's action. So let's say simulator is running at 10 FPS or 20 FPS and the VLM is running at 2. Well, if you take 10 divided by 2, 5, then it should accumulate 5 frames in the future and like sum those all together, because this is working on delta XYZ and delta yaw pitch roll controls. So if you like sum that all together over its future horizon, it should be able to train itself more into like the future of and be more predictive as opposed to like reactive on just what the current frame is. And then couple that with having the prior state of the model. But certainly a lot of these researchers, like they don't need to go through the trouble of deploying the Jetson on the actual device. And yes, they're all in like kitchens now. Everybody's building the same IKEA kitchen to like test this all in, which is only, in my opinion, it's good because it's both good and bad, because it shows like the art of the possible. They want to like do it, and it's like a good proxy for us, right? Everybody wants one of these to go chop vegetables and cook dinner for them, right? That's a very applicable, tangible application of AI for people in the real world, right? But we also want to get this thing outdoors or like in other environments that have nothing in common with those, and being able to deploy like on device with no Wi-Fi or cellular, it will be important. And like doing this for like UGVs and all that, we have plans to do that too, which hopefully will be easier than the full 7 degree of freedom manipulator, which is like one of the hardest tasks in robotics, which is why they're working on it and applying like the latest Gen AI tech to doing all of this. So it has been great over the past 2 weeks. We did get this whole like workflow working where like the data makes it all the way through, the models are training, we're getting incremental improvements. Now we just kind of have to like keep working at it and applying all these things that we're learning. And I think in the grander scheme, it's very valuable for everybody to like learn fine-tuning practices, doing LoRa's. Shaggy's started us off like a month or so ago with doing the Llama factory, right? And then since then, we've started on this out of necessity to the point where we're running cloud systems to train it for limited durations, which really wasn't that bad versus what folks have like built up in their mind. But much like we saw with Nano, when people start doing their own object detectors and things, once you start training your own model, that's really when you kind of like take ownership over it. That's when the really specialized, unique applications in the field start to come out. And, everybody can become an AI guru by, applying themselves and trying this, even if it's just like doing a little LoRa on Llama or whatnot to add some characteristics or whatnot, like Shakizat did with like the Disney characters and whatnot. Okay. Anybody has any feedback or like wants to work on this together, please feel free to hit me up. This whole physical AI is like the manifestation of everything that we've worked on in edge computing for almost 10 years now. And we're really getting there, and it's exciting to see this. I think probably for another week or so, I will keep working in sim and fine-tuning these models. But before long, I want to get working on the actual robotic arm and do the whole like sim to real thing and like real world deployment, because all of this work to date is just to get all of this workflow pipe cleaned and easy to use. And we'll like do the tutorial as soon as it gets like, I don't know, I would be happy with like 50% success ratio or like 70, whatever the paper is. And we're just trying to reproduce the paper in this sim environment essentially for everybody to do. All right, thank you guys. Asier, if you wanted to take over and share with us what you've done with Gemma 2B. Okay, great. It looks like you got your background going there. Are you muted? Can we hear you?
Okay, now?
Yes. All right. Thank you so much.
Okay, good. Okay, good. So I'm gonna share quickly my screen, and then I'm gonna jump to the demo. So basically, we have tested the Gemma 2 billion parameters model on the Jetson Nano, and it is performing really well, like 12.5 tokens per second on one of the small models. The quantization is 4 bits. And the interesting thing about Gemma 2 is that the reasoning is very similar to GPT 3.5 at some point. So this is a very small language model. It's not like a large one, and it's performing really good, very close to some large language models. And it's super easy to install in the Jetson, even if you have the Jetson from scratch. So the tutorial, which is posted out on LinkedIn, probably we will post it somewhere else, is intended to build it from scratch. So you install the basics, you install the build essential, you install CUDA if you don't have it. Then you clone. We did it with Gemma CPP and with Llama CPP. Llama CPP is very straightforward. Dustin will prepare a Docker container to launch it much better. So we will put this tutorial on the Jetson AI Labs website together. If you want to speak on that, Dustin, let me know.
We just have to update the build for that. The Gemma 2, they added a PR for it a few days ago, and we'll like refresh the container for that. But Llama C++ is one of the few that, like, as Jim and I were talking about before this started, with like, if you don't want to use containers, Llama C++, it should be your jam, because it like builds basically straight away. It only depends on like Kublas. So that one is very easy to use. Yeah. And the performance isn't 100%, but it's good enough for text. Yeah.
Yes. So it's pretty close to 100% now. So when you build it, it will
take... the MLC gets like 2x the perf on the other ones that we've benchmarked. But MLC is like trickier to use, and like I need to go back and rebuild that too to gain the Gemma 2 support. But Llama C++ is by far like the most popular open source, locally hosted API, and like we do recommend that for people getting started in Llama, and this is probably in Llama by now as well.
Yes, and I will show you some examples of what you can do with Llama, which is pretty awesome for how easy it is to configure. So basically, you build it just like 2 commands. You download the models from Hugging Face. Basically, you have a lot of models right now. Probably soon we will have the Q2 somewhere. So they're from Q3 to Q8, even the full precision one. And basically, you just run it. So I'm going to share quickly my Nano, which is connected to my computer. So probably you can see me now. Can you see the screen? Yes, okay, good. So I'm going to do a quick demo with one surprise also. So I'm going to enter in the Llama build. And here I have the command, so I don't need to write everything all the time to save some time. So I'm going to run just a quick test saying what the meaning of life. And as you see, it's running quite fast. It's launching quite fast. It's running quite fast. And it's performing at 12.5 tokens per second, kind of 12.5. You will get now the stats. So this is the speed. The good thing about Llama CPP is that they have a built-in server, which is this one. So you can run this in a server, and they just updated the UI, which is much better than before. It's more like beautiful to use, at least. So this is going to run a server on localhost 8080. So I open incognito window because the memory that it takes is too much. So sometimes Chrome is very, very slow. And we will do another test now with a bigger model. The one more thing, and you will see how it performs too. So I'm going to go to 8080. You will see this interface. You can click new UI. And basically here you have different options for different models. In this case, we don't have yet Gemma here. So I have written a quick intro. So this is the typical pre-prompt for the system. And let's see if this is, yeah, this is okay. So I'm going to say something quickly like, hey, what's in your mind today? Okay, let's say something a bit crazy to see how it behaves. Like, hey, I am in a Cessna and I need to land. I have an emergency. Let's see. For example, if the chatbot tells me how to land. Oh my God, that sounds terrifying. Okay, give me the indications, please. Okay, so as you see, well, the reasoning is kind of good. So it reminds me a bit to yes, ChatGPT 3.5. It's not like super specific, probably also because of the quantization we did, and this is not like the 9 billion parameters model. So probably it's not going to tell you what speed you need to land. So this kind of like very fine details. Maybe if I try to do some tests, it could get there. So this is just a quick demo just to show you how it works.
It's a friendly model. Yeah.
Yes, it's very small. So with 2 billion parameters, you cannot do a lot for now. So it's performing really well. And it'd be
interesting if like it did the function calling too, because that would be like the smallest one that would. Perhaps Llama Factory would support this, and you could add, because Llama Factory supports the one of the function calling data sets, and you can just like add it in there, and then we could use this on top of things.
Yes, one of the interesting functions it has, so Gemma 2 and Gemma, I think, they have this kind of sliding window for the context. So I put here
like Mistral.
Yes, so I put here a text file which has the transcription of the last public NVIDIA earnings call. So basically, this is a big context, like more than 8,000 tokens.
It essentially has like unlimited context, kind of.
I need to test it more. I started doing this test, but probably we should do maybe in another call. We can show some tests on this.
And test it against the Llama 3.1 128K. Yeah, because I haven't even really played around. Like, do some needle in the haystack tests on it.
Yeah. So I'm going to run this command. In this case, the window is 2048. This is the sliding window, and the tokens, the context is 8,000. And this is also the GAN, which is the like how many tokens you read. Basically, you read the context in packets of like 16 tokens to optimize it. So I need to test this with more time and compare. But I think we can create a very nice model to summarize very big files in 2 billion parameters. So now we need to wait a bit because it's like reading the context. It's gonna take like 10 seconds, 20 seconds maybe, and then it's gonna start doing the summary. So this is the.
So it like summarizes as it passes through the whole context. It like summarizes all that down to fit within the context window. That is interesting.
It is very interesting, and it's doing a very good job.
There are lots
slower,
of,
as you see.
Llama C++ is really good with having these like alternative.
That's why I say that Llama
there.
is very interesting. Yes, because it has these options.
And it's very unstable. But like, and they were first with like speculative decoding, and I know their VLM support is like not super long-term stable because like new model and VLMs are like can be a real pain to support all the different stuff and encoders in them. But Llama C++ is always like one of the first out with like these new things that people try, and this is definitely one of them. This is really cool. It's kind of like a built-in RAG that does not rely on an external vector DB. It just like compresses the context window. Play around more with this and share your findings.
The last thing, because we have one more speaker, so I'm gonna do a quick one running the 9 billion parameters model, which it runs not very well because the memory. So sometimes I need to like reboot. But if you improve you make bigger the swap memory, it works. So wait.
Yes. Even on AGX OREN, I use that. Sometimes I'm using like 30 gigs of swap for it, and it is nice, Asier, that like you're able to get this on OREN Nano, which I wish I had more time to focus on myself. But I think we can work together.
Yes, and I'm struggling a bit with launching at the same time the web server, but that's doable, like 100%.
Yeah,
I need to like
do all that. Yeah, and we have the EDU discount back active for this, guys, at $299. It was like $399 before.
So this is the 9 billion parameters, 5 tokens per second, 5 tokens per second, which is pretty good. And
5 tokens a second is verbal rate, so like that's fine for conversational AI.
And to end, I'm gonna crash the Nano probably. So I'm gonna try to run the server. It's okay. I think I can keep the parameters. Let's see if it runs. Oops, what I'm missing? Okay, yes, sorry. I need to remove this server. This is the live thing.
I think, there you go.
Yeah, this one.
There's lots of options.
Yes. I'm going to open the incognito window to save some memory, but probably if we use a smaller...
The whole Llama project is predicated on Llama C++. You like needing to read the docs for it. You know, it's like that project. Llama is like super popular because it's like it's one click Llama C++ essentially.
Yes.
I wish they would all.
Sometimes it launches in 20 seconds. Sometimes it crashes, but probably
it's probably all the swap. Do you have NVMe on there?
Yes, NVMe 2 terabytes and a very good one. But let's see quickly. Or if you want, we can jump to the other one. Nah, it's not. So it could work, but it will take some time to to write it's writing now. So yeah.
Some of these things, they take a while to load. Thanks, Asier. Yeah. That is great. Like basically the first day we do get latest SLM support, just like recompile it, wait for the PRs to hit upstream. And in advance, sometimes we get drops of these models for partners and like check out that it works and make sure that it's good for everybody to go out and do. All right, thank you so much.
It is running now. It is running.
Okay. So show it again.
Yeah. Go to the next because I don't know if we have time, but here it is. So I'm gonna use this one. I don't want to force it more. So I cannot even type. So I type hi, and after 10 seconds, or let's.
It's hilarious.
See
They
if it
made
works.
they made their own web UI that's like just like super
Yes.
basic, much in the likes of Llama C++. Like
or without the environment, without the graphic environment, probably we can do that. We can have a Jetson server with the 9 billion parameters just for that.
Or you can do
And
Open Web UI or TextGen Web UI.
Yes.
It's fine.
I click it, but even the mouse is not responding. So
okay.
Well,
yes,
like I think this is a good challenge. This is a good challenge to fix it. So I think we can fix this soon. So
it's never taking for granted.
First thing you can do is to, when you're out of memory, the first thing you can do is to turn off the desktop GUI. So if you
that's what I'm saying. Yeah, like creating just the web server and you use it from another computer. So
right.
Yes.
Yeah. Okay.
Lakshantha,
are you there?
Okay. Let's move.
Yeah. Sorry, I meant to give Lakshantha time, and we can go a few minutes over. That's entirely fine. Because they did make this nice tutorial for the Jetson AI Lab.
Okay. Thanks, Dustin.
Yes, we can hear you. We can't see your camera
there.
if you're trying to screen share or anything. We can't see that yet.
Yeah, I'll start.
Okay, we see you now.
Share. Okay. Yeah, sure. Let me start my screen. Can you see my screen?
Yes, we can. Thank you.
Okay. So, hey guys, I'm Lakshantha, and I work as an embedded computer vision engineer at Ultralytics. So I mainly focus on deploying YOLOv8 state-of-the-art computer vision models on edge devices such as NVIDIA Jetson, like Raspberry Pi, Google Coral Edge TPUs, and other embedded hardware. So, Ultralytics YOLOv8 is a cutting-edge state-of-the-art model that builds upon like previous iterations of YOLO versions, and we have improved with new features and also improved the performance of these models. And this YOLOv8,
honestly, I would say it's like the most popular model in I mean, I would say the world, but like Llama is the most, but it's still YOLO is still, that's what everybody is still deploying today. Yes, we are getting into Gen AI and Llama and everything, but everybody is still doing object detector and YOLO, and Ultralytics has long been the mainstay of that. And fortunately, you guys have like coalesced all of the different YOLOs and the fragmentation. Now I think most people are on YOLOv8 now, and you got TensorRT integration. So thank you so much for figuring that out for everybody.
Yeah, for sure. And thank you for because I think we had the discussion a few weeks ago. You were like, okay, so can we have a guide at NVIDIA Jetson AI Lab? And I was happy to kind of contribute to the NVIDIA Jetson AI Lab, because I from what I've seen, NVIDIA Jetson AI Lab kind of revolves more around the LLM, VLM space,
not
more on the CV space, right? If you see, So, but I think it's a good opportunity to contribute in the CV space.
Totally. Yeah. And over time, we intend to add, we're actively working to add sections for ROS and the Metropolis stuff and Holoscan and all these other things that it doesn't need to be Gen AI. The original title of the site was the Jetson Generative AI Lab. We dropped that part. Now it's just the Jetson AI Lab, because we use lots of stuff. This whole stack we built up over the past 10 years is now all coming to bear. And yes, the object detectors are still what most people's applications, you need to find something very in particular and very accurately. And, YOLO is great at that.
Right. Yeah. And also okay, so when it comes to detect, okay, we have classification tasks, detection tasks, segmentation tasks, tracking, and also post-estimation tasks supported by Ultralytics YOLOv8 models, right? So, without going before going further into this document, I want to spend some time on our repo. So this is how we started our Ultralytics GitHub repository, which is very popular within the computer vision community. So we have a lot of users already utilizing the Ultralytics package to deploy their computer vision models on different hardware platforms. So So if you check this repository, like, okay, so you can install it's a very simple pip installation where we host our Ultralytics packages on the PyPy, and also we offer two different ways of interacting with our Ultralytics package. So one is using the CLI, right, and another one is a Python. Another one is using Python, where you can simply like build your custom computer vision applications to integrate the Ultralytics package. And so we offer pre-trained models, right? So there are different pre-trained models, YOLOv8, starting from YOLOv8 N model all the way to the YOLOv8 X model. So the difference is like these models get larger and larger with like the parameters getting larger. But as the parameters get larger, the speed becomes a little bit less. So that's kind of like a, you know, trade-off between the model size and the performance, the speed. So and also there are like different integrations with different platforms, Ultralytics, and
So
we
is
also
it
have Ultralytics. Yeah.
Lakshantha, is it the same models that do segmentation, kind of like Florence and these new like multi-function VITs that are coming out, or is it like different checkpoints that you've trained for like segmentation versus classification versus detection?
I'm sorry, could you repeat that, please?
Do the same model weights do segmentation and detection, or is it like
no, we have different model weights. Yeah.
Okay.
So
Yeah,
these
but it's all
model
under
weights,
one
yeah. So
Okay.
these model weights are for detection, right? So if
Yeah.
it's for segmentation, you can see like if you go here, these
Got
are
it.
the
Okay.
sorry, these are the segmentation. So they are named as .seg, and for the post. So we have different
Okay.
checkpoints for different tasks.
Different weights, but it's like a shared architecture or shared backbone, which enables you to like leverage the same workflows, and like TensorRT still works and all of that. Okay.
For sure. Yeah. And also we have kind of like a no-code platform to training and deployment, which is called the Ultralytics Hub. So that's and we also have a mobile app where you can like download on like Android or like iOS, and you can simply like test these YOLOv8 models running on mobile. Like it will inference on device. Yeah, it's just for testing. Yeah. And also like
Shakiza and some others from the group have been experimenting with that and running these on like mobile devices and stuff, which is great. Oh, Chris Kersey's been looking into it also for his heads up, and it's great that over time we see this technology making its way into like the smallest of all devices, little ARM SoCs and everything. Obviously, Jetson is on, especially with like the AGX, that we're out in front bringing this stuff to the edge, and over time we will see it start appearing like everywhere. And it's great that you built this like open platforms. The code is open source. The models are open. It would be great to understand your roadmap for YOLO in the future. Are you like, what kind of architectures are you looking at? Does it include vision transformers or still CNN based or other research that you're doing? I know Glenn, your CEO, he's like a great guy, and all you guys on the team are awesome in like the dedication that you've had to computer vision at the edge. So thanks. It's been great to collaborate with you guys over the years.
Yeah, definitely. And yeah, so as you mentioned, like, okay, so we are actually constantly improving our models and also adding new features to the models. So we have this big event coming up in September, which is the YOLO Vision, so which will be on the September 27th, right? So it's kind of like our like annual event where we bring different like partners and different like community like members from the community, where like everyone will gather and kind of have some discussions, and so this kind of event which will be in Madrid, Spain. You have
your own It's in Madrid. Okay, that's
Asier,
you should go, man. Yeah, that's great. You have your own like developer conference for YOLO. It's gotten that like, but you guys can all come together and make like YOLO V10 or like whatever the next one there is. We'll come out of this with like the VLM version of YOLO or whatnot. Chen, you had a question, buddy.
Yes, good question. Thanks so much for sharing. I mean, YOLO is big for our
Yeah.
community, and we have a lot of company even trying YOLO on Jetson. My question is on the benchmark number. Do you? I see because internally we are also running some benchmark, and there's some
Yeah.
the
Can
number
you
is
switch
quite
back to
different.
the Gen AI page?
Yeah, I think
Lakshantha?
we are getting into benchmarks. Yeah, later. Yeah.
Yeah, I saw
Yeah.
I saw
Okay.
that in the
Yeah,
Gen
this
AI
one.
page.
Okay. All right.
Yeah.
Yeah, for sure. Okay. Yeah.
Yeah,
All right.
just curious,
Yeah.
did you get a chance to utilize both GPU and DLA on Jetson, or this is just a GPU number? Because I see this number is
Oh,
slightly
yeah.
lower than
Okay.
what we have internally.
Yeah, correct. Okay, so this is without the DLA. It's just on the
Got you.
GPU. Yeah, it's
Got
not utilizing the DLAs. Correct. Yeah.
Gotcha. And
Yeah.
what is your
Yeah.
batch size for running those number? Do you use dynamics batching, or like what is approach? Because we also see dynamics batching make a difference in terms of the performance. So just curious on your how you get the number and how we can improve the performance.
So you're saying like you guys also run the same benchmarks and you got different numbers? Is that what you're saying?
I think they
Yeah.
are slightly different. It's like
Slightly different, yeah.
ML perf, and we have a different like harness for this. It might be I'm not exactly sure they're the same checkpoints or not. But to Chen's point, like yes, those do leverage multiple batch sizes, and in theory, lots of these Jetson systems have multiple cameras on them. So yes, you could. I would say you could see up to batch size 4 or 8.
So normally, yeah, for sure. So normally when we run benchmarks, the default is like using batch equals 1. So that is what we use for validation.
And I think
right?
the one, first one should show batch 1 because you want the lowest latency. That's what everybody expects. Okay.
Oh, okay.
Yeah.
I see.
Yeah.
Because I feel like maybe the improvement we can do together is to make sure DLA at least being captured.
For sure.
This is because sometimes people look at those number and compare it with the other offerings outside. So we want to make sure we have the maybe best possible benchmark number that is accurate.
The
and
DLA for sure.
Definitely, yeah. It will be like great to have this kind of DLA support as well, because from our side, when we run the Ultralytics benchmarkings, we don't like it will not utilize the DLAs. To be honest, it will only use the GPU. So, are there any insights into how the DLAs can be utilized as well in the pipeline, so that we can also collaborate on that?
How are you using TensorRT today? Because that's just a flag in TensorRT that you set. Are you using the TensorRT Python API or Torch to TRT or the TensorRT C++ API?
Yeah, for the TensorRT,
I haven't actually dug into your code, but I can point you to it.
So it should be it should be the Python API.
Yeah, it's just some flags that you set in the engine builder that say, okay, use DLA 0, use DLA 1, and that engine will then be specifically built for DLA. You need to like track that, oh, I built an engine, but it's for GPU or like whatever, and then rebuild it for DLA. And when you go to execute it, it will just run on DLA instead. It will be slower, okay, but because GPU is faster than DLA, but DLA is more efficient and it's offloaded and would enable us to do things like running LLM at the same time you're doing a full 30 hertz, 60 hertz YOLO stream on the DLA, which is like pretty compelling.
Right, but I think if you want to do that, it should be only like targeted to a Jetson, right? So if we integrate this DLA pipelines into our TensorRT, right? So it should focus only on the Jetson, because we are like Ultralytics repository like is targeted mainly on the the consumer GPUs, right? So NVIDIA Jetson is kind of like the other side of the things. So
understand. Yeah. But hopefully it is just like one flag that you set. And I think over time you will see more interest in these like accelerators that will end up deploying YOLO as well, that you should think about targeting those too.
Definitely, yeah. I think this is something that we will look into, so that we will kind of see how this can be integrated through our the TensorRT Python API, and have the DLAs enabled as well, and kind of get the benchmarks like better than right now. Yeah.
And again, this is already like good out of the box on the Jetson AI lab. We never say like this is ultimate like performance. NVIDIA takes a lot of this stuff that we do out and like go productionizes it, and the ML perf team takes it and like works their magic and gets like 6,000 FPS on. I think it's actually close to like 2,500 or it's something absurd on the AGX, to the point where like, okay, it's doing like 32 streams of HD at the same time through deep stream and all these advanced techniques, which is awesome for like production deployments of things. But for just getting like started really easy, this is awesome. And like you have the containers on there. Thank you. I think you're the only person other than me that still builds containers for Jetpack 4, and which is like the ultimate pain point for folks that like they just get their Nano, they want to pip install Ultralytics, and boom, everything like blows up. But so thank you for the containers to make that work for everybody out of the box.
Yeah, definitely. Yeah. So this is where you see all the work that is done for the containers. Yeah. Before coming to the containers, I would like to mention that when it comes to TensorRT, like there's my colleague Berhan from Ultralytics. He did a lot of efforts on doing this TensorRT pipelines and integrating TensorRT Python APIs. It makes a huge difference. He's also in our meeting today, and he's been there in the chat. Right. I saw.
He's the guy. Yeah,
he's right there. He's the guy in the chat right now.
Okay.
Yes. Yeah. So he did awesome. A lot of contributions for TensorRT. Yeah. So like coming back to the Jetpack. Oh yeah. Before so we are building these Docker containers for different Jetpack versions, Jetpack 4, 5, and 6. And so as Dustin mentioned, like there were so many users in the past where they were not able to run Ultralytics YOLOv8 models on Jetson like nano devices, right? The legacy devices.
It's Ubuntu 18.04 and Python 3.6. I remember Ultralytics was one of the first ones that like required 3.8, and everybody was like,
So I mean, so now like they also can utilize our Docker containers, and they are actually hosted right here on Docker Hub. So we actually build these containers using GitHub runners. And once the containers are built, we push all the containers to the Docker Hub, right?
Awesome.
Where you can find all the Jetpack containers.
Yeah. I appreciate you guys being very personable out in the community, put a face to like the name. We're just like out there working this, making the models and inferencing the best as we can to enable everybody to go off and build cool stuff with it. And YOLO is consistently like up there. It's always like state of the art. And if it's not, somebody came out with another YOLO version to like be the best. And in the ultra scheme of things, it is interesting. Like there's this whole YOLO movement that I'm sure is awesome to see in person at your YOLO developer conference coming up. So that's great. You kind of like coalesce the community in there. Because I think that's the major concern over it is like anybody can come out with their YOLO V20 or like whatever. There's so many variants.
It keeps going.
Your CXC the most
it never
popular.
ends.
Yeah, and that's why I never supported YOLO in Jetson Inference and Hello AI World, because as soon as I would do it, another one would come out. I'm like, I can't keep up with this. But like you guys have taken on that burden. So thank you so much. And have a great event. And if you add anything more to this, come back and Burhan can try DLA and come on back and tell us how it works.
Definitely. And I also want to have a shout out right here, because like to do all these benchmarks, like Elaine Wu from Sage Studio was provided us with all these Jetson devices. She provided us with the Jetson Orin NX device, the Recomputer J4012, and also the Jetson Nano device based on the Recomputer as well to test out the Jetpack 4. So shout out to Elaine from Sage Studio. And also some of the benchmarks are all also done by Sage Studio. We have also highlighted right here in this documentation.
Yes. And that is great. And like Seed, they make that awesome Recomputer NX 16 gigabyte box, which like I've been meaning to try that thing out myself. And much like Ultralytics, Seed Studio has been great to have here in this group in the community. And it's awesome to see like everybody coming together, just like working together on on all of this stuff to push the state of the art at the edge. Okay, there's Elaine. She's always here. It's probably like, it's like 3 a.m. her time. It's probably late for you guys too. So with that, we'll wrap it up here shortly. But thank you, Asier, Lakshantha, Patty, Elaine, everybody who contributed to this meeting today. Really appreciate it.
And also definitely like go into our GitHub repository, and if you have any questions, you can just post issues on the GitHub repository, and also like join the Discord. We have a Discord, like very strong Discord community. So if you have any questions or anything that you want to ask, just like go into those forums, and just come there, and we'll be there.
Yeah.
Thank you, Dustin.
Yes. And I felt like maybe we should like start some like Discord or whatnot. I know NVIDIA does have one for like the developer forums, although like LinkedIn, there's a lot of people chatting back and forth there too. If that is something that you guys want to do, we can we'd be happy to do that and hop in there. I'm already going like 24/7 on all this. So like what's more there? Okay, let's catch up with the chat real quick here before we say goodbye for today. Baran, you had your hand up there. Did you have a question to ask?
No, I hit the wrong button. Sorry about that.
Okay, no worries. And thank you so much for all your work on TensorRT and everything that you did in YOLO. It makes a huge, like the streamlining of that deployment flow is, super appreciated. Okay. There was somebody who asked about using CUDA streams for inference in the past. And yes, like in the Agent Studio and all those demos that I show, at some point a couple months ago, I had to go back in and implement everything on its own CUDA stream, basically, because there were so many different models running all at the same time. They all can't be on the same CUDA stream. And most people's demos, aren't necessarily architected for that. So if you're ever making like APIs for models or whatnot, always have the option to accept an external CUDA stream that users are able to supply and run that model on, because they might have their own pipelines set up that relies that. And even I had to go back and add some APIs and expose those. If you ever notice in like the official NVIDIA docs, like every API comes with the option to supply the CUDA stream for it, because it is actually important once we like really start scaling these applications up. All right, well, with that, thank you so much, everybody, all our presenters today. Great meeting as usual. Our next one will be in another 2 weeks on August 20th. And we hope to continue making progress on that. I will keep training the VLM and update you guys, and really hope to have an actual actionable tutorial out for you guys to follow and play around with that by then. I think given the pace of our progress, we will definitely get there. Asier, Lakshantha, keep up the good work, guys. Really appreciate it. With that,
thank you, everyone.
Say goodbye. See you guys next time. Thank you.